Hey, what's up, folks? How's it going? This is Aviz here, and welcome to DevOps Challenge Hub. So let's start with today's interview question. And today it's going to be an interesting session. Today's question is, what is Amazon SQS and how does it work? So I'm going to show you one demo where I'll show how DevOps engineer is using SQS, ACS, and SNS. And also at the end, we are going to have quiz. So stay till the end. You can pause the video, attempt the quiz. So let's start with SQS. What is SQS and how does it work? So SQS is simple queue service or message queue service. So imagine you are waiting in line where messages wait until a worker is free to pick them up. So you went to a doorstep, you want to order some coffee, dosa, idli, etc. So you bought it from the counter, cash counter, and you got a slip. And a slip you give it to the food counter. So one person he is collecting all the food that slip, and he is putting in the order. And the cook he is picking it up, right? But if that person who is collecting the slips, if he's not there, if you directly give it to cook, so you have to wait because cook will pick up one order, one slip, and then he will be busy cooking, finish that, and give it to you. So it will be tightly coupled. So to decouple the system, in between we have that one guy. You give the slip to that person. He put them in order, put all the food orders, and cook will pick up one by one from the queue, from the message queue. So this is like nothing but a message queue. So imagine a waiting line where messages wait until a worker is free to pick them up. It helps decouple application, meaning one system can send messages without worrying if the receiver is ready at that exact moment. So there can be 100 customers, they can give a food slip, like whatever they have placed order to that person, and he will put them in order. This cook is not may not be free. He will be picking up at a later time, maybe after 15 minutes, maybe after half an hour when he is free. So that's how you are decoupling the system. So how does it work? Producer sends message to SQS queue. SQS stores the message safely until it's processed. And customer, another application like microservice, EC2 or Lambda picks up the message. So there is producer, like for example here customer in the Darshini SQS stores, where that middleman or the person who at the counter taking up the slips, that the message queue. And the consumer is basically cook will be picking up that message and act based on that message. So now in a Darshini customer place the order at the counter, and like a producer sending a message, it may be cashier writes the order in a slip, or the pay at the counter, cash counter, and then go to the food counter and give that food slip. And he puts in the order board like SQSQ, safely storing the message until it's ready. Then cook picks up the slip from the board and prepares the dish. Like a consumer, is it to Lambda, other service, processing the message. And after cooking, slip is removed from the board. They will remove it from the board, like deleting the message from the message queue after successful process. So customer and cook never directly talk. Customer and cook, they are not going to talk directly. And producer and consumer not directly talking. In between, there is a message queue. So slip or queue act as a middleman to ensure orders are safe and processed in order. If the cook is busy, the slip just waits on the board or waits on the queue. So this is the message queue. So some DevOps use case, like you run a website where user upload large video, then video uploading takes time, and then after that you have to do transcoding and compression, etc. That takes time. So if user directly waits for server to process, the website will be slow. After uploading, it will be sent into a queue. So all the transcoding job will be waiting in the queue. Then one by one, the job picker will pick up that job, will compress the video and put it into S3 bucket. Again, pick up another video, compress it, and put it into S3 bucket. So this is like a web app is a producer sends video processing request to SQS, simple queuing service. Worker service running on EC2 or Kubernetes consumer picks up message one by one and process the video. This way, your website responds instantly without while processing happens in the background. Processing happens in the background. So uploads a video, web app sends a message, to SQS. SQS holds the message safely. Lambda function or S2 worker pulls the queue, processes the video, and stores output in S3. After success, worker deletes the message from the SQS. So why DevOps engineer need to bother about this? Because he has to think about the scalability. Add more workers if message picks up. Right, like there are 100 customers coming, but only two cooks are there. It won't help. The customer waiting time will increase half an hour to maybe 3 hours. So in that case, you need to add more cooks. Like right, so scalability, add more workers if message pile up. Reliability, message should not get lost. Whatever message customers are giving, it should not get lost. Right. Decoupling system don't crash if one part is slow. Let's say there are only two cooks. Other cooks are on vacation, and there are 30, 40 customers are coming. Like if there is no middleman, they will all these 30, 40 customers start asking, please take my sleep, take my sleep. And like the cook will be confused. He's cooking, also preparing dosa idli, and in between customers calling. So that will be difficult for him. So the system will crash. System to decouple, if we decouple the system won't crash. That's why we have message queue, even if one part is slow, because cook will be slow because he has to prepare the food. I'm just giving analogy. Monitoring CloudWatch metrics on queue length shows system health. The monitoring CloudWatch will monitor like what is the system health. So Amazon SQS is a fully managed message queue service, fully managed message queue service that decouple producer and consumer. Decouple producer and consumer, ensuring reliable, scalable, and asynchronous communication between application component. Asynchronous communication between application component. So this guy doesn't need to wait. This guy gives the order and comes, returns back and do his own job. So they are not tightly coupled. They are decoupled because of this message queue. He placed the order, like a WhatsApp message, your friend sends the message. Maybe morning you will wake up and then you got a message from your friend in US. And morning you wake up, you pick up that message. Right? So it's in the queue. This guy doesn't need to wait for you to pick it up. So your message is not lost. Difference between standard queue and FIFO queue in SQS. We'll see the demo after this. Okay. So what is the difference between standard queue and FIFO? Standard queue is fast. It has a focus on high throughput, faster, scalable, but not order is not guaranteed. Let's say you're going to that food counter, only one person is there, and there are like 30 customers are coming at one point of time. Everybody is giving this take my food slip. So he's collecting all the food slip and putting them in the board. So it may not be in order, right? Because he collected all the slips quickly. So he quickly putting them up, right? So it may not be in order. So, but it's fast, standard queue. But FIFO means fast in, fast out. Now that guy says, no, all of you stand in a queue. One by one you come and give me the slip. I will take the slip, put this, and then again I will pick up another slip, then I will put it in order. So that will be a little bit slower, right? So standard queue focused on high throughput, faster, scalable, but order not guaranteed. FIFO queue is fast in, fast out, focused on order and exactly once processing. Slower but strict message order is there. Strict message order. So message order based effort ordering may arrive out of order. Standard queue out of order may happen. Strict ordering is FIFO. Strict order is there. Standard queue at least once, duplicates possible, and FIFO no duplicates. Throughput nearly unlimited, thousands of TPS. This is little limited FIFO queue. Use case big data logs task where order doesn't matter. Some cases order doesn't matter, and FIFO where financial transaction where order matters. For example, CICD system where multiple builds are there. So multiple builds are there. So the build system sends the build, and someone has to pick up one by one and run the build. So worker will just pick up one by one. So order doesn't matter, right? Whether if they're like independent, 1, 2, 3, it can be 2, 3, 1 like that. But in payment system, you gave 100 rupees, then 200, then took out 50 rupees. So that order has to be maintained, right? So it cannot be like out of order. So financial transaction must be in order, right? So there you will be using FIFO queue. Otherwise, Like if order doesn't matter, go for standard queue. It's faster. FIFO queue will be slower. So that is the difference between standard queue and FIFO queue. So this like producer sends ABC and queue delivers ACP, order out of order, right? FIFO queue strict order ABC and queue will also deliver ABC, same order, always same order. So if you go for standard queue when scale and speed matters, order doesn't matter, duplicates also doesn't have. FIFO queue, you need accuracy and order, even if it is slower. So standard queue, speed and scale, and FIFO queue, accuracy and order. You want order, then go for FIFO. Now let's look at the demo. This demo Avantika submitted. Let's see what she's doing here.
Okay, so I'll be explaining what is SQS, SNS, and SES do. Now let's imagine we have a server of around 100 users. Now the application suddenly starts throwing errors like 100 of 500 internal.
Yeah, so what she's doing like here, you have application, and application suddenly started throwing error, and there are 100 users, they are using it. So for each user, like it will generate error. Maybe within 5 seconds, some 100 users simultaneously logged in and it threw some error. So 100 errors will be coming. And if you directly send all 100 errors by email, DevOps mailbox will be flooded. So he will see 100 emails within 5 seconds. So that's not useful. So all the 100 emails, you put them into SQS, it will be in like in SQS queue, and then pick them up. Maybe after 2 minutes, every 2 minutes you process. Every 2 minutes you count how many 500 errors are there, how many 403 errors are there. Every 2 3 minutes you count and create a summary and send out by email. So SNS is like a simple notification service. After SQS queuing service, you will have notification. So it will it will go to the notification service will pick it up, and then through ACS, that is a simple email service, it will be sending out the email. So that's the whole concept here. Otherwise, what will happen? A mailbox will be flooded. So let's see.
Server errors every second. Now, if we want to send email to the DevOps engineer, the inboxes will be flooded with thousands of messages in a few minutes itself. And this creates more noise than help because he cannot actually see what's happening because of so much ongoing traffic. Now, what AWS has done is introduced us to this SQS, SNS, and SES services. Now, as you can see, this is the SQS, Amazon SQS. It is a message queue. You can consider this as a waiting room where all the messages line up. And it helps us decouple the producers and consumers, meaning the system generating errors are not spammed to the DevOps engineer directly. It is first safely stored in the queue, which helps in segregating how we are supposed to send the messages to this engineer. Then comes our Amazon SNS. Now the SNS is a notification hub. We can use this to broadcast messages to many subscribers at the same times. We can use it for emails. We can use it for SMS, webhooks, Lambda functions, etc. It can be used to alert multiple channels with just one action. So we usually create a topic first, which I've created over here, which is this one, and a subscription later on. Then we have the simple email service, which is the SES, where we can use it to send and receive reliable and verified emails. Now, the use case we're going to solve here is that we're using a Python script to generate multiple internal server errors, and the Python script will generate errors every second, and all these errors first go to SQS, Then we have a consumer program which processes them.
Yeah, in ideal case scenarios, that error will be there in the CloudWatch. From CloudWatch, it will be coming to SQL simple queuing service. But here, she is adding like simulating using Python script. Python script will get every 1 second errors, and that error will be pushed to SQS queuing service. So it will be queued. All the errors will be queued, like hundreds of messages. And basically, she's trying to simulate that environment where user is trying to log in or user is trying to do some activity. 100 users are trying to do together, and hundreds of errors are getting generated. So instead of that, like she has created a Python application which will be pushing hundreds of errors in a second or in 5 seconds to SQS queue.
This is the duplicates and also summarizes them. Now, this summary is published to SNS, which in turn sends to SES and delivers one clear email to the engineer. For example, instead of having thousands of emails, we are getting a summary of this one of all the errors which has occurred in this one email. Now, to create this, we first go to SQS. In SQS, I have created a queue. To edit this is just a standard SQS queue, which is named error queue over here. And we have saved this. Then we go to the SNS. First, the SNS topic is created. Now let's see the topic. This is called the error summary topic, which basically is the summary of all the errors which are appearing in 1 minute. Then a subscription is created with the same name, and the ARN is added to this topic. After this, we go to SES and verify the email. So as we can see, we go to the identities and add the email address, and we verify it. After this, I'll configure my AWS to my console. So we can do this by going to my console. As you can see, I have configured it here using my IAM user. We have created two Python files, one error generator and one consumer aggregator. Now, error generator sends errors every 1 second, and the consumer aggregator basically aggregates all of these errors in the past 60 seconds and then sends an email. Now, as you can see over here, I've run this for 15 minutes, and there's been a lot of errors which are generated. After this, I can go. I run my consumer aggregator. I run both of them at the same time so that it can catch all these errors and send to the email. Now over here we can see that the summary is generated, where 500 internal server error is generated 53 times and forbidden error is 11 times. Now, if I want to go to my email, I can go over there and see that the AWS email is continuously generated, and it has sent me around 15 emails over here to show that. Let me just show it. Yeah, as you can see, there's around 17 emails over here, and it shows it sends a message every 1 minute saying that what error appears and how many times does it appear.
So it's a greater summary, 500 internal servers, 985 times. So instead of 985 emails coming, it's just creating a summary. So there is like a producer which is producing a lot of errors, and consumer running every 2 minutes or 1 minute or 3 minutes, or you can set the time 10 minutes, 1 hour. It will check the SQS. It will see that, okay, there are 100 errors, same error. So based on that, it will be sending out the message. Okay, so now let's go to the quiz section. You can pause the video and try to answer. So what is Amazon SQS mainly used for? What is Amazon SQS mainly used for? Store large file, manage serverless API, send, store, receive message between distributed system. Between distributed system, you can send, store, receive messages. Send, store, receive messages between distributed system. Message queue service decouples producer and consumer for reliable communication. Decouples producer and consumer for reliable communication. In the Dostani analogy, what represents the SQS queue? Cook, you can pause the video, try to answer. Cook, preparing food, customer placing the order, slip placed on the order board. Slip placed on the order board is the SQS skill. Right? Slip placed on the order is the SQS skill. The answer is C. How does Amazon SQS ensures messages are not lost? Message producer store shipped until consumer process again. So how does Amazon SQS ensure messages are not lost? Because messages are stored safely until a consumer process and delete them. Until a consumer process and delete them, it's kept safely. Until a consumer successfully process and delete them, ensures reliability. Which of the following is best explains the difference between standard queue and FIFO queue and SQS? Standard queue is faster, right? Standard queue faster. We order messages, but message may be out of order, but FIFO queue is slower but keeps strict order. So answer is A. Standard queue, speed and scale, but out of order allowed, duplicates possible. FIFO queue, accuracy and order, strict order, exactly once delivered. What is the best use case for FIFO queue? You can pause and try to answer. What is the best use case of FIFO queue? FIFO queue best example is we need order, right? Order payment transaction where the order must be preserved. In the payment transaction, order must be preserved. In DevOps video processing system, why is SQS useful? SQS is useful because users should not wait. Decouple the system. This video transcoding takes long time. It ensures users don't wait for long processing tasks directly. Right? So that's why we need to decouple the system. B. Answer is B. SQS holds video processing requests so users don't wait, worker process them asynchronously. So that's it for today. Hope you like this video. Please like, share, and subscribe to my YouTube channel, and also follow my LinkedIn page, DevOps Challenge. I post quiz contests daily, and you can participate in them. And follow my WhatsApp communities where I post daily jobs, career tips, interview tips, etc. Thank you for watching this video. See you again in the next video.